Hello guys, welcome back to our channel Biolab, and this is Vamsi here at Biolab, and in today's video we will be discussing in more detail about the reabsorption topic. Already I have started with the reabsorption topic of PCT part of nephron. I have also told you some controversial thing that is given and mentioned in your NCERT about K+. And yes, once again let us revise the PCT part and then move on to the rest tubular parts also. So revising the PCT part, proximal convoluted tubules, what are being reabsorbed in PCT, what are being reabsorbed and what are being secreted. The reabsorbed things are HCO3, NaCl, water. Nearly 70 to 80% of the things are done itself in the PCT part only. K plus, glucose, amino acids, essential nutrients. These all are being reabsorbed in the PCT, proximal convoluted tubule part of the nephron. But what are being secreted is H plus or hydrogen atoms, or you can call it as protons, etc., and NH3 ammonia. NH3 ammonia. Ammonia is not necessary for our body, so we secrete it into the primary urine or lumen, what you call it. So we secrete it into this. Now this is about the PCT part. Now coming to the DCT part, sorry, not DCT, descending limb of loop of Henle. Let us see the DL part. This is from here, it is a little easy to remember. Okay, descending limb of loop of Henle, or you can call it either way, descending limb of Henle's loop. Okay, you can call it either way also. Now it is permeable to water and impermeable, sorry, ions. Now tell me, if it is permeable to water, water should be reabsorbed. So water is reabsorbed. Water is reabsorbed, and it is impermeable to ions. Ions are neither reabsorbed nor secreted. Ions are neither reabsorbed nor secreted. Ions are neither reabsorbed nor secreted. So as it is permeable to water, water is being reabsorbed when you are going down the descending limb of loop of Henle. When you are going down, water is being removed. So what happens to the concentration of the urine that is formed in the descending limb? When with respect to the medullary fluid, the concentration increases gradually when you are moving down. So when you are moving down the descending limb of loop of Henle, the concentration gradually increases. Why? Water is being reabsorbed here. Water is being reabsorbed here. This is very important. Water is being reabsorbed. What happens to the dilution? Dilution decreases. Dilution decreases. See, every time dilution is inverse to concentration, right? Concentration. If dilution increases, concentration decreases. If concentration increases, dilution decreases. And also dilution is also related to the water content. So if less amount of water is there, it is more concentration and less diluted. If more amount of water is there, less concentrated and more diluted. So the same thing happens here, and this point you have to remember. The concentration of the urine gradually increases when you are going down the descending limb of loop of Henle when compared to the medullary fluid. This is your medullary fluid. We have two nephrons, types of nephrons I will be taking after this reabsorption. I will be telling you after this reabsorption. Okay? That is about the descending limb. What is being reabsorbed in descending limb? Water. What is neither being reabsorbed nor being secreted? That is your ions. They can also ask you while moving from top to bottom through the descending limb, what happens to the dilution? Decreases. What happens to the concentration? Increases with respect to the medullary fluid. While coming next one, it is here Henle's loop or hairpin bend. This part. So wait. This part. Henle's loop or hairpin bend. The concentration gradually increases, and here it becomes equal to the medullary fluid at this part. Since there is no reabsorption, there is no secretion of any kind and any sorts of materials. So at the hairpin one, what is the speciality is the concentration of the urine becomes equal to that of the medullary fluid. Medullary fluid. So that is the thing which is happening. Means at the hairpin bend, the urine is isotonic to the medullary fluid. While in the descending limb, while moving down in the descending limb, it is hypertonic to the medullary fluid. And while now this is about the hairpin bend, there is no absorption, there is no reabsorption, as well as there is no secretion. So that is why it becomes isotonic to. Isotonic means if this is your selectively permeable membrane, the pressure on this side equals to the pressure on this side. Okay, that is the thing. The concentration on this side will be equal to the concentration of this side. So this condition which is present is called as the isotonic condition, and it is maintained at the hairpin bend because there is no reabsorption, there is no secretion of any sorts of material near the hairpin bend of the loop of Henle. Now, coming to the next part of the tubular thing, that is your thin ascending limb and thick ascending limb. Generally, AL of loop of Henle. Ascending limb of loop of Henle. This parts. During these parts, the maximum thing happens is your concentration is balanced because of the counter current flow. Before going into this, it is very simple that DL descending limb, it is permeable to water, impermeable to ions, and as it is counter current flow, you can simply remember like this. In ascending limb, the urine flows upwards. In descending limb, urine flows downwards. So since descending limb is permeable to water, ascending limb is impermeable to water. Remember, like antagonist functions, impermeable to water. and permeable to ions. So what happens? Ions are being reabsorbed, mainly NaCl. NaCl is reabsorbed here. NaCl is being reabsorbed here. Impermeable to water, permeable to ions. Now here in the descending limb of loop of Henle, while going down, the concentration of the urine is increasing and dilution is decreasing. Now here, since it is impermeable to water, water is staying inside, ions are going outside. So the concentration while moving from down to top, or from bottom to top, or while going through the passage of the urine in the ascending limb, the concentration of the urine decreases and dilution increases due to the reabsorption of ions. So here the medium is hypotonic to the medullary fluid. I'll be telling you those values in the next lecture when I discuss about the osmotic concentration and all. So there I'll be telling you. So that is why here it is hypotonic, since it is permeable to ions. Water concentration inside the urine increases and outside decreases, and it becomes hypotonic, and the dilution increases. Here dilution increases, concentration decreases. This is the point you have to remember in ascending and descending. Remember the antagonistic function of these two. Then you can identify what is happening, where the concentration is increasing, where the concentration is decreasing, where the dilution is increasing, where the dilution is decreasing. You can identify easily when you remember the functions as antagonistic functions. Now coming to the last part of the tubular reabsorption, that is your DCT part. This DCT part, it is very similar to PCT part, except for one thing, that reabsorbed things, you will be identifying the difference soon. Secretory. Reabsorbed NaCl, it is same for both H2O, it is same for both HCO3 minus, it is same for both nutrients, glucose. These all are only absorbed in the PCT part, reabsorbed. Now identify the difference. It is lying, or you can also say it lies in the K+. Here it is secreted, there it is reabsorbed. K+ is reabsorbed in PCT and it is secreted in DCT part. Okay, it is reabsorbed in PCT and secreted in the DCT part. So that is the difference that you have to see, or you have to notice it. Okay, you have to notice it. Now coming, that is it for this DCT part. Now coming to collecting them. After this I will be sharing you some important, interesting information. CD, collecting them. Here urea is reabsorbed. Urea is reabsorbed here. See, urea is reabsorbed. Water is also reabsorbed. Urea and water are being reabsorbed here. Now the interesting thing is, the urea which is reabsorbed by the CD is secreted by, or it is secreted into the urine by thin AL, thin ascending limb of loop of Henle. See here, urea is being reabsorbed and it is again secreted, reabsorbed, secreted. Why is this happening? This NaCl reabsorption, see here NaCl reabsorption taking place, here also NaCl reabsorption taking place, and this NaCl which is reabsorbed is sent into the vasa recta. Since we have the peritubular network and vasa recta also is in counter current flow with counter current means one downwards, second one upwards, like this. It is in counter current flow with these parts, these tubular parts, and the NaCl is being secreted into the vasa recta and reabsorbed by the tubular part, that is Al part, and the urea is being reabsorbed by CD and it is being secreted by air. Now what is happening here? This is happening because in order to maintain the osmotic pressure difference between the medullary fluid and the urine. So if this osmotic pressure is not maintained properly, then it may affect on NFP, net filtration pressure. Yesterday I have told you, which is 10 mm of Hg, 10 mm of Hg. I have already told you this. NFP, it would affect on NFP. In order to avoid this osmotic pressure balance or osmotic difference, in order to avoid this osmotic difference, these substances are being reabsorbed in some part and secreted in another part. So the urea which is secreted in this part is again reabsorbed by this part. The same amount of urea which is reabsorbed by this part is being secreted by this part. The same thing goes with NaCl also, but here NaCl is with vasa recta, but not with the tubular parts. And that is it with the reabsorption. We are being left only and only with 1 minute guys. Let me check now. With which topic we are being off. Role of other organs in excretion. Next one. This mechanism of concentration of filtrate and role, I will be regulation of kidney function, I will be completing in one lecture, the next lecture, and role of organs, I will be role of organs and disorders, I will be completing in one lecture. So rest 2 lectures. So as per our plan, 3 lectures. In 3 lectures, including this lecture, we will be completing the excretion. Okay, in the next lecture, please be patient while waiting for the topic, that is osmotic mechanism of regulation of filtration pressure. And that is it for this video guys. Hope you like the video. If you like it, please hit that like button and also subscribe to our channel Biolab. And this is Vamsi signing off from Biolab. Thank you guys. Have a great day further. Thank you.